The last type of hybrid orbitals that we're going to look at are the sp hybrid orbitals. And this will be the case when we have just two electron domains about a central atom. So for example, BeF2. Beryllium has two electrons in that 2s shell. And by that, you might expect that it wouldn't form any bonds. But in fact it does. So we excite an electron to that 2p shell, and we get a configuration that allows me to form two bonds with each of those unpaired electrons. Let's get rid of those extra ones that I drew. And then, because those bonds are observed to be equivalent in the structure, we must come up with a theory that will explain that. So again, we must hybridize or mix them. So we only mix the two that we need for bonding. That's the sp hybrid orbitals, one part s, one part p. And those other two p orbitals remain unhybridized, and they will be empty. So beryllium will have the sp orbitals on either side, and it will have the empty p orbitals. This is one p orbital, and the other p orbital will be perpendicular to that at 90-degree angle. So it will have two empty orbitals on its atom. In this carbon-containing system with the triple bond, we have two electron domains about each carbon atom. So the steric number here is 2. So we would need two hybridized orbitals to form these sigma bonds. So we'll have our 2s and our 2p. Carbon has 4 electrons, and skipping to that excited state, we're going to hybridize the ones that we need to form those sigma bonds. We only need 2 of them, so we start with the lowest energy and then the next lowest. So I'll end up with my sp hybrid orbitals, and my unhybridized 2p orbitals will be available to form those pi bonds that are necessary to form the second and third bond in that system. So looking at my balloon pictures again, the sp orbital is going to be a little bit more spherical because it is 50% s character. So we'll try to reflect that here in the drawing that I've done. And then we'll have another sp orbital off of this side, which will overlap with the s orbital for hydrogen. And then we have those p orbitals. Again, they'll be 90 degrees from one another. So that's a little bit hard to illustrate here. And then same thing over here, we have a p orbital. This is one p orbital, this is another p orbital. And in and out of the board, this is a p orbital, p orbital. So these will overlap above and below. And then these will overlap in front and behind the board. Of course I omitted this, but this would be an SPS. So this is a sigma bond, sigma bond, sigma bond, pi, and pi. So we can explain the bonding and draw a balloon picture, which I probably won't ask you to do, so don't work too much on this, but it's nice to, I think, to see the picture of what's happening with the atomic orbitals. So see if you can predict the hybridization in some of these other systems. If you have any questions as you're practicing, please reach out and let me know. Thanks for watching.